Hello everyone, we are discussing Unit 11, that is alcohols, phenols and ethers. In our previous classes we have completed or we have studied about alcohols and phenols, their IUPAC nomenclature, their method of preparation, physical and chemical properties, and then we have discussed some important chemical reactions of alcohols and phenols. So in today's class we will discuss ethers. So at first we will discuss physical properties of ether and then preparation of ether. So at first let us discuss what are actually ethers. So ethers are organic compound having the ROR or ROR- functional group. Here the R represents one alkyl group. Okay, the R may be either CH3 or C2H5. Okay, so ethers are the compound having these functional group. And then let us discuss nomenclature of ethers. So simple ethers are named as, if the ether is unsymmetrical, then alkyl ether, and then if the ether is symmetrical, then it is named as dialkyl ether. Okay, so symmetrical ether means when both the alkyl groups along both sides of oxygen are same, and unsymmetrical ethers are those when the alkyl groups are different. So ROR is symmetrical ether and ROR- is unsymmetrical ether. So you always remember that in case of unsymmetrical ether, the name is given as alkyl ether, and in case of symmetrical ethers, the name is given as dialkyl ether. So these are the ways for writing common name of ethers. But for IUPAC names, the name is given as alkoxyalkane. Always remember, the part having higher number of carbon atoms is considered as alkane, and the other part having lower number of carbon atoms is considered as alkoxy along with the oxygen. So first one is diethyl ether. The common name is diethyl ether because both the alkyl groups are ethyl groups. But when we consider the IUPAC name, then the name is ethoxyethane because in both part same number of carbon atoms are present. Therefore we can use any one part as alkoxy and another part as ethane. So the alkoxy part is ethoxy and the alkane part is ethane, since two carbons are present. In next compound, the name is ethyl methyl ether. This is the common name, ethyl methyl ether. That means two different alkyl groups are present. First one is ethyl and then methyl, and you always remember the alkyl groups are named in their alphabetical order. In alphabetical order we have to write ethyl first and then methyl. So ethyl methyl ether, and the IUPAC name is, consider the part having less number of carbon atoms, that is CH3 along with the oxygen. When we consider the alkane having one carbon, then the alkane is methane, but in this case we are considering along with the oxygen, therefore the name is methoxy, and then the alkane is ethane, since two 2 carbon atoms are present. Okay, so we have learned how ethers are named for their common names and then for their IUPAC names. Then let us discuss physical properties of ether. So in case of ether, 2 lone pair present in the oxygen atom and the shape is similar as water, having bond angle 109.5 degree. That means the bond angle is 109.5 degree. Okay, and ethers are generally polar due to electronegativity of oxygen atom, and since the oxygen is not bonded with hydrogen atom, therefore ethers have moderate melting and boiling point. Okay, hydrogen atom is not bonded with oxygen, hence hydrogen bonding is not present in ether. Okay, and then ethers are generally water insoluble, but always remember that lower ethers are soluble in water due to formation of intermolecular hydrogen bonding with water. Ether cannot form intermolecular hydrogen bonding with each other, but ether can form intermolecular hydrogen bonding with water, and hence lower ethers are soluble in water and higher ethers are insoluble in water. Okay, and one question usually arrives in exam. The question is, explain why ethers have lower melting and boiling point than alcohols. The reason is, in case of ethers, intermolecular hydrogen bonding is absent, but in case of alcohols, intermolecular hydrogen bonding is present. Therefore ethers have lower melting and boiling point than alcohols. Okay, and then diethyl ether is very important organic solvent. It is polar in nature, water insoluble, and its boiling point is 35 degrees Celsius. Due to its low boiling point, it is very flammable and forms explosive peroxides. Okay, that means diethyl ether catches fire very easily. Okay, and it is very high risk to use diethyl ether without proper guidance. And then let us consider industrial synthesis for diethyl ether or simply ether. Okay, so at first, when ethanol is heated with H2SO4, that means sulfuric acid, at 413 Kelvin or 440 degrees Celsius, then the product is diethyl ether. Okay, and water, and this reaction is known as dehydration of alcohol. But always remember, the temperature is the key factor for the reaction. When the temperature is 440 Kelvin or 108 degrees Celsius, then the ethanol is converted into ethylene or ethene. Okay, and hence this reaction is very important. Generally the temperature is very important. Okay, and there are some limitations of this method. By this method, only symmetrical ethers can be prepared, and since the condition is very specific, therefore mixtures of alkene and ethers are formed when the temperature is not maintained. After that, another method. The first one is industrial method, and the second one is very important method, and this method is known as Williamson synthesis. During Williamson synthesis, sodium alkoxide is treated with alkyl halide. This one is alkyl halide, and then sodium halide is formed along with ether. The previous method was not useful for preparation of unsymmetrical ethers, but using this method we can simply prepare unsymmetrical ethers. Okay, but in this case the alkyl halides should be methyl or primary. Secondary and tertiary alkyl halides do not give ethers, and the reaction follows SN2 mechanism. That means substitution nucleophilic bimolecular. So about SN1 mechanism and SN2 mechanism you have studied in chapter 10. Okay, let us consider how the reaction happened. At first, when we used the alcohol with sodium metal, then sodium alkoxide is formed, and then when another alcohol is treated with hydrogen halide, then alkyl halide is formed, and they both combine to give the ether. The example is this one is isopropyl alcohol, and when isopropyl alcohol is treated with sodium, then isopropyl sodium alkoxide is formed, and again this one is propanol. When propanol is treated with HBr, then 1-bromopropane is formed, and both of them combine together to give the ether. In this case we are using only primary alkyl halide, but we can use secondary and tertiary sodium alkoxide. So we have learned about how ethers can be prepared by Williamson synthesis. Now let us consider what happened when we used secondary or tertiary alkyl halides. So in next example we are using primary sodium alkoxide and secondary alkyl halide, and in this case the product is not ether but the product is an alkene. Okay, so in today's class we have learned about how ethers are named accordingly, common name and IUPAC name, and then we have learned about physical properties of ether, and then we have learned about two important methods for preparation of ether which are in our NCERT book, that means in our syllabus. So in our next class we will discuss chemical reactions of ether. Okay, so that's all for today's class. Thank you.